Hello everyone, welcome to this month's Serverless London meetup. We've got a great speaker this month from AWS, Luca, who will be talking about hexagonal architectures with AWS Lambda. If you have any questions during Luca's talk, make sure to pop them in the chat because we'll do a Q&A at the end. And before I hand over to Luca, I just want to thank our sponsors, Theodo and Senzo. Without them, this meetup wouldn't happen. But with that, over to you, Luca.
Thank you very much. Thank you for having me, and welcome everyone to this session. I think, one thing that I learned in the last almost 20 years that I'm working in this industry is that having a good modularity in your code base really help you to achieve iterative changes inside your code base. And that is not always easy to think about that, because at the beginning, maybe you start with a few lines of code, and then slowly but steady, you start to become hundreds and so on and so forth. And if you don't pay too much attention on the modularity of your code, you risk to find yourself on a very bad legacy platform that is very difficult to maintain and evolve. And that's basically the whole point of my talk today, talking about how you can evolve your code base using hexagonal architecture. My name is Luca Mezzalira. I'm a principal solution architect at AWS in London. I'm an international speaker and an O'Reilly author. So let's start with the first concept of this talk, that is evolutionary architecture. I don't know how many of you are familiar with the book Building Evolutionary Architectures that was published quite a few years ago by 3 people from ThoughtWorks. But basically, the concept of evolutionary architecture can be summarized in supports guided incremental changes across multiple dimensions. And what it means is basically having the possibility to finding the right trade-offs based not only on the technical trade-off, but also organizational structure and following the business evolution. Because the reality is, architecture is not, let's say, a dimension per se, but it is part of what I call the free handshake between architecture, communication flows, and let's say business evolution. So we need to think about these multiple dimensions and find the right trade-off of what we want to do, bearing in mind that as the business is evolving, architecture should evolve alongside it. I think everyone, at least once in your career, had the opportunity to work on what is called a 3-tier architecture. So the possibility to have different layers for defining the presentation layer, application layer, and data layer. And more often than not, when you have a monolithic architecture that is composed by those layers, you risk that at some point over maintaining, after several months or even years or decades in some cases, your code base, that inevitably there are some leaks between the data layer and the presentation layer towards the application layer, because maybe you need to rush to develop and deploy a new feature, and therefore is easier to do that in the application layer. And that definitely doesn't help when you want to evolve your code, because if it happens once or twice and then you have the time to fix the tech debt, yeah, happy days. But sometimes it's not feasible, and therefore you maintain this code base for longer. That is far to be ideal. Another thing that I experienced myself firsthand was this challenge. So moving to AWS Lambda from a different compute service. So imagine that, for instance, you have a container that is running on ECS, or you have an EC2 machine with some code that is running there, and you want to move to Lambda. I have to say, if you don't have a very modular code, you risk to have more than one challenge to move to one or multiple Lambdas. Depends from the context, obviously. The other thing that I've noticed more than once is that usually when you look at Lambda implementations, Well, more often than not, you have a mix and match of domain logic with infrastructure implementation and interaction. So, for instance, in this case, as you can see, we have Lambda that has a request, and then you have the body validation that I omitted for this example. But because then you have inside after the body validation, you have like these two functions: the submit candidate and candidate info, and those basically, after being fulfilled, you have like the response for the for our Lambda. But what is interesting is what you have behind those functions. And when you check them, you have at the beginning with submit candidate info and interaction with infrastructure, in this case with DynamoDB. And you have also a bit of domain logic, a value object in this case with the candidate info. So you are basically mix and matching those different concepts together with your infrastructure. That is, again, far to be ideal, especially when you want to evolve your code, because then you start to create, let's say, more abstractions, and often we don't have the time to, let's say, modularize our code properly in the long run. So that is where Hexagonal architecture could help you to create a proper modular architecture that doesn't provide too much overhead if tackled properly, and it could help you to achieve a proper evolutionary architecture with your Lambdas. Hexagonal architecture, as described by the creator, Alistair Cockburn, allows application to be equally driven by user, programs, automating tests, or batch script, and to be tested in isolation from its eventual runtime, devices, and database. So basically, if we want to summarize what Hexagonal architecture does, allows us to divide and modularize our code base in a way that simplify the evolution of our, in this case, Lambdas. So if we want to look at the anatomy of this approach, we can see that, first of all, we have the first, if you want, hexagon, but layer in this case, that is the domain logic. So we are wrapping or modularize the domain logic and encapsulating inside his own hexagon in this case. Then you have ports. That is the only way to access from the external world to the domain logic, and the other way around. So the domain logic has to pass through ports every time that it wants to interact with the external world. Usually ports, depends from the language that you're using in your Lambda, are represented by interfaces. And in this case is as simple as an interface. In the example that we are going to that I'm going to present this evening, it would be in Node.js with ES6. Therefore, we don't have the possibility to implement interfaces like you could do in TypeScript or Java, and therefore we are going to use just simple functions. But the concept stands. And moreover, you have adapters. And if you're familiar with the design patterns of the adapters design pattern, it is basically allowing you to map two different contracts and having the internal domain that is communicating with the external domain in a simple way through adapters, and all the logic for, let's say, wiring these two contracts is wrapped inside and encapsulated inside the adapter is exactly what it is here. And it will be used for the communication with external world, input and output communication. So moreover, you have also primary actors that are the actors that are interacting with the service. In this case, we can be another service, another microservice, for instance. It could be a front-end application, mobile application, or it could be a message queue if you want to have an asynchronous interaction. At the same time, you have secondary actors that usually interact with the hexagonal architecture because maybe the domain logic needs to retrieve data from a database or store some data in a database. Or even if we want to compute something and then store inside the message queue, or even if we want to fetch from a third-party service. So all those are some of the options that are offered by hexagonal architecture. But as you can see, the architecture is very simple, and it's not even too complicated. We have domain logic, we have ports for let's say interacting with the domain logic, and we have adapters that are interacting with the external world. So the benefits and drawbacks of this approach. So first of all, on the benefits, we have a domain logic that is agnostic from the outside world. We can, let's say, wire independent. We can evolve independently from the external services. Our business logic is easier to test in isolation because through this encapsulation, it became easier to, let's say, use a different way. For instance, if we're using API gateway for triggering our Lambda, we can easily mock it, or we can easily use a different, let's say, input for our Lambda. The same is for the secondary, let's say, for the second part on where we want to interact with the database. We can mock it easily if needed, or we can switch very easily our adapters for testing in locally at other parts. Finally, we lower our technical debt, and this is because of this encapsulation. If you think about wrapping those different, let's say, logic in multiple layers, it became quite straightforward that the evolution of those parts are atomic. So we can change specific part without touching anything else. And therefore, if we need to make a change of the business logic, we are not going to touch anything about the adapters, and vice versa. Some pitfalls we have, obviously, that we are building more layers. So upfront, you don't have just one file where you can collect everything of your logic and your code. And the original implementation in 2005, when was defined for the free tier architecture that we discussed before, it doesn't provide too much guidance on how to implement the domain logic. So those are the pitfalls that we can find in this approach. Now, if you are wondering by now why hexagons, why not any other shape for describing this, Alistair Cockburn provides also the information about that. So the hexagon is not an hexagon because the number 6 is important. Is because it provides enough surface to represent the interaction with the external world. Because we realize that having just a few sides of a rectangle, for instance, in this case, for representing a layer is not enough nowadays. And I totally agree. The interaction that we can have with the microservice is definitely more complicated. Potentially could be more complicated than this. And in fact, hexagonal architecture or the hexagon are often represented when we want to represent the microservices. That is often referred that the microservices were, let's say, the hexagonal architecture was the initial concept around representing microservices. So I prepare a demo for this, very simple one, but I want to show you, let's say, a real implementation of hexagonal architecture, because I think it is important to see the code and not just discussing abstract concepts. So the demo that we are going to see is this one. As you can see, very simple. So what we have is a currency converter. And the idea is that we create an API where we pass a stock ID. And this we retrieve first from, in this case, a Dynamo table, the value of the stock that was passed through the API. Then at the same time, it will retrieve some currencies, real-time value of the currencies on specific currencies. In this case, would be US dollars, Australian dollars, and Canadian dollars. And it will apply this value to the stock value that was retrieved in euros. And then it will return back the final response to the client that requests that. And that's what we are going to discuss today. So if we want to visually see how the hexagonal architecture would work in this case, when there is a request that is coming from, in this case, an API gateway, what's happening is that the adapters will pick up the request. It will communicate through the port to the domain logic. The domain logic, in that case, when receive the stock ID, will first fetch from a DynamoDB the value of the stock ID. So in this case, it will pass through the port, and then an adapter will wrap all the logic for communicating with DynamoDB. And then after that, the business logic will also communicate through the port by an adapter with a third-party service for retrieving the real-time value of the currencies. And when you have those two pieces of information, we'll compute the final, let's say, a response that will pass to the adapter of the HTTP request, and then the adapter knows what is the final response that the client is expecting. So as you can see, there is a strong separation of concern. We will see in a moment that there is also a strong encapsulation of those concepts. And let's jump straight into the code, I would say now. I hope that is big enough. Let me make bigger. First of all, I would like to catch your attention on this, the structure of this project. So first of all, we have adapters, domains, and ports folder. And as you can see, there are quite a few files for a very simple application, but that's why I'm saying with hexagonal architecture, you need to spend a bit of more time on creating the files, but the overhead is, in my opinion, worth it. So let's start with the code. What we have is this one is the entry point of our Lambda. So it's the handler that we have, as you can see here, that what it does is just retrieving the stock ID from the parameter. Oh yeah, let me show you first another thing that probably makes more sense just to understand. So this is, as you can see, the request. So as you can see, I have this API gateway that is exposing the stock API. I can pass an API, in this case, Amazon ID, and I retrieve those values. So the euro one and then the converted one to different currencies. I can obviously change something else. Let's say Apple one. Boom, and you have the Apple one with the value in euros and all the others converted. So that is what we are going to discuss. And here in the entry point of our Lambda, we are going to retrieve basically the stock ID, that is the last parameter in my REST API, and pass that to an adapter. As you can see, I have the adapters is called getStockRequest. So this one, what it does is ES6 is everything asynchronous in this case, and therefore we are going to use async await very often. And this is very simple. So it's just using the port and passing the stock ID. At the same time, when the response will come from the business logic, is going to prepare the message to return to the client. Very simple as implementation. When we go to the port, as any other port, you will see that we have just, in this case, because I repeat this, because we are not using a language with interfaces, we are going to use just a function. But obviously, if you're using, I don't know, Java or TypeScript, you can use interfaces for, let's say, decoupling basically the adapters from the business logic. Moreover, when we go to the business logic, what we have is something very simple. So we have only the business logic. So we are saying, I want to retrieve the stock ID first. As you can see, there is no, let's say, information around where I should fetch this information. It could be a third-party service. It could be a DynamoDB, like in this case. But what it says, I want to talk with a port. This is called a repository. And I want to pass this stock ID. And then I want to retrieve the currencies data, and I want to find those currencies. And then when I receive those two information, I start the compute and I apply the value of the stock value to the different currency rate. And then I will return this information to the initial adapter that make the response to the client. So now the interesting part of this business logic is, first of all, is, as you can see, no inference of anything related to the either response to the client or infrastructure. The only thing that we are describing here is the application logic and how it should behave. And that is very, very important, because then it becomes easier to test specific things. But moreover, it became, let's say, easier to evolve our business logic atomically. So if tomorrow there is a new change on the business logic, we don't have to change anything around the request or the interaction with the infrastructure. The only thing that we are going to change is here inside the business logic. Now, from the business logic, there are a couple of other interesting things. From here, let's go first to the repository, therefore DynamoDB. So this is, again, a port that, as you can see, doesn't provide any logic around which database we are using. But when we go to the adapter, here we have all the logic related to DynamoDB. And that is interesting because once again, here we are encapsulating all the logic of my interaction with Dynamo. And the beauty of this is that if tomorrow I want to change for any given reason Dynamo with another database, again, I'm going to change only this adapter, and I don't have to do anything else in the rest part of the application. Even more interesting it becomes when we go to the third-party service. So in the third-party service interaction, I go to these currencies, and as you can see here in this port, I'm calling the currency converter, that is my adapter, and the adapter has this, let's say, a signature. So I just make a request using the Axios library, if you're familiar with JavaScript or Node.js in general, where I'm fetching basically this information from a third-party API. Now, let's assume that you are, and so far nothing too strange, right? I'm just fetching this, but let's make a concrete example. Let's assume that we publish this application in production. We start to get traction, and the people really like the application that we developed. And now suddenly you need to make a change. You are currently using a third-party service, and you realize that you have some API throttling that is happening inside your service, and therefore you need to figure out a way that you can easily change this implementation, introducing a cache aside pattern. With the cache aside pattern, basically what happens is that you first check in the cache if there is some value, and then you want to, if the value are not available, you do the fetch from a third-party service. This basically will offload all the traffic towards the third-party service, and you're using the cache as a primary source of truth for retrieving temporarily certain values. And if you want to implement something like that, what we need to do is just go into the port, remove the comment here and add a comment on the first adapter. And just with this change, what is happening is that we have a completely different application. So we are using Redis, so Elastic Cache with Redis for, let's say, interacting with this. So as you can see from the logic, the first thing that we are doing is retrieving from my Redis cluster if there is any currency value available. And if there is, we are just returning the final value to the port, and therefore the business logic. So in this case, the business logic is not changed. The only thing that I change atomically is creating, in my case, a new adapter, but potentially you could, let's say, change the initial adapter that I showed you. And when, let's say, I don't have the currency key available in my Redis cluster, I perform the request to the third party, and then I store immediately this information, so the response basically from the third party to my cache, in order that the next Lambda will fetch directly from the currency from the Elastic Cache cluster. And here I also set an expiration or eviction time for my cache of 20 seconds. That is as simple as that, but once again, I just need to change one part atomically and nothing more. Okay, so you have seen how to structure basically my application with Hexagonal architecture. Let's play another example. So let's assume now that instead of starting directly with a Lambda, we start with something else. So in this case, with a container. So as you can see here, I have exactly the same files and exactly the same code. Nothing changed apart from the entry point. The entry point here is interesting. I'm using Fastify as web framework for my container, and let's assume that we have, in this case, I just use the get API. But let's assume that you have maybe a CRUD implementation where you have, like, you want to update a record, or you want to create a record, or you want to delete a record on top of reading a record. So in this case, using let's say the same implementation of Hexagonal architecture, it becomes very clear that when I have a get, this is exactly the same code that I have inside my Lambda handler. What does it mean is that if we are using this approach, it becomes easier then to take and decompose and refactor maybe my code moving from a container towards a Lambda, because in this case, I'm already doing the heavy lifting on modularize my code. And also potentially I can also say, you know what, the traffic pattern for my read are definitely overcoming the create and update and delete APIs by, I don't know, 10x factor. What I could do, instead of creating one Lambda per let's say version, I can say, okay, I create first of all a Lambda for my read traffic, and I extract that, and then slowly but steady I can extract all the other parts. And because of that, the effort of let's say moving between different compute offering, it became easier, because you already done the modularization that you have to do, and instead of taking months basically for migrating and wrapping the code around different things, because you create this modular approach with hexagonal architecture, moving between different compute services is becoming trivial. Now that you have seen also this example, let's move back to some use cases that we can leverage this architecture. Okay, so I identify a few use cases. So the first one is obviously testing, and that was the initial purpose of hexagonal architecture. So when Alistair Cockburn in 2005 decided that that was an architecture pattern to propose to the community, definitely was having this in mind. And in fact, we can test in isolation our business logic without too many problems, and we can mock different adapters, and we can do quite a lot of things thanks to this modularized approach. Another thing is the cache aside pattern. We have seen this. So you have a service that is start to hammering your Lambda, and then instead of always go to straight to the database, you can use first the check the cache, and then when the cache expire, you can go to the database. The interesting part is that this is applicable also with third-party services. So it's not only with database that you are under control. The other thing is you want to change trigger. Let's imagine that you have a synchronous invocation of your Lambda through API gateway, and you want to move to something asynchronous because now the requirements are changed and you want to evolve your use case. However, in this case, for this requirement, the trigger changed, but the behaviors remain the same. So again, you don't have to change all your code base and touch multiple files. The only thing that you need to go is in the adapter side and change with change the payload and retrieve the data from, in this case, SQS, and it becomes easier than to not touch anything else inside your Lambda logic, because only the adapter has to change in this case. So also service migration becomes fairly easy. Why that? Because when you, for instance, let's assume that you have a self-managed MongoDB cluster that you are using for your Lambdas, and you want to move to let's say a managed service, in this case DocumentDB. What you can do is at an adapter level, start to implement what is called a branch by abstraction pattern. And what it means is that you start to have an abstraction layer between your communication with your database, and you start to say, okay, I want to make, I want obviously to do the snapshot of the data between Mongo to DocumentDB, and maybe a routine that is doing that every now and then. Then I will start to have some read on DocumentDB, and then slowly but steady I migrate my content from MongoDB and remove totally my self-managed cluster and rely on DocumentDB. But because you are using this modularized approach, branching by abstraction becomes quite easy, because we have already an adapter there that is communicating with the database, and therefore this adapter can implement also the branch by abstraction logic and have this let's say gradual migration towards another service. This is for databases, but it could be for other migrations. And once again, instead of doing a switch on-off from between adapters, you can do also a gradual implementation, because everything is wrapped inside just one piece of your code base. Another interesting use case that I identify is when you want to move from a modular monolith towards microservices in this case. So modular monolith is the first step that you should take if you have monolithic architecture or monolithic code base in order to identify what are the domains that your system is serving. And then when you identify them, you modularize them. So you are trying to create some boundaries around those modules. That would be the first step towards then moving to microservices. You can obviously skip that step, but there are many companies that currently are using this, adopting this intermediate step. And sometimes they stop at the modular monolith more than moving fully to microservices because it's modular enough for what they need to achieve. But in this case, if you're using hexagonal architecture, once again, it became easier, as we have seen, for instance, from the container to Lambda, moving the logic from the container to Lambda, it became same as easy as it should be, moving from a portion of a modular monolith towards multiple microservices. That is always great. Another approach that we have seen is moving from microservices to lambdas. And in this case, we can take multiple, let's say, REST verb and split them in multiple lambdas. It's also true the other way around if for any given reason you have to do that. Finally, hybrid strategies. If you think about this approach can really provide a very interesting approach when you have to run your compute logic and your compute service in multiple in an environment that is on-prem and on AWS. So if you have your domain logic ports and adapter with the hexagonal architecture, what you could do is, for instance, doing this. So it's maybe having a Knative that is running on-prem, and then having the business logic and potentially also the ports. It depends how obviously you are going to structure the things that is shared across multiple environments, because at the end of the day, what you're going to change on-prem will be probably the adapters. And the business logic, although remain the same, and because you modularize your code in a certain way, it became easy. And those are a list of obviously some of the use cases that identify. I'm sure that if you spend more time, you can find even further use cases. The last one that is quite aveniristic, I really like this one, is the petalite architecture. Petalite architecture is basically the idea of providing the same behavior of developer experience when you work with microservices, so multiple teams working in distributed code bases, but then you are going to deploy that in production as a monolithic architecture. So therefore you have, let's say, way less, so you don't have like a representation one-to-one of your microservice with some compute layers. And that is an interesting approach that is a bit experimental right now. And the only person that I have seen so far talking extensively about petalite architecture is Adrian Cockford, that is working in AWS now, but he was previously the chief architect in Netflix. If you're interested about the topic, he issued a couple of interesting talks and podcasts around the topic. With that said, obviously, as I said, one of the pitfalls of this approach was the fact that it wasn't too opinionated on the business logic. Turned out that after 2005, a couple of other implementations were trying to fix this problem. And the first one is the onion architecture, and the second one is the clean architecture. Both of them are providing a more, let's say, opinionated way how to structure your business logic. So instead of saying you have business logic, you have entities, use cases, and so on and so forth. Now, would I suggest them? Oh, definitely. If you have a use case that are valid for structuring your code, are totally worth it to check. In my opinion, if we are following the recommended practices on trying to have a AWS Lambda function that contains just some part of the logic of a specific application, it should be enough working with hexagonal architecture. But definitely, if you are creating a more, let's say, chunk piece of your logic inside inside the Lambda function, you can structure your code with the onion architecture or clean architecture. Both of them are using as a base let's say concept hexagonal architecture. So if you master hexagonal architecture, you will be able to switch to one of them very quickly. So now the question that probably you are asking right now is this the definitive architecture? Are we should use hexagonal architecture for every Lambda or serverless workload? But my answer is, as good architect, is it depends. It depends from the context, and I truly believe that there is still a valid use case for, let's say, creating some lambdas that maybe, as we have seen in one of the previous slides, you map basically all the domain logic and infrastructure together. Maybe because it's a project that you need to I don't know, trash it in a couple of months, it's a POC, or maybe it's a project, it's a lambda that you're not going to touch anymore for long time. But there are certain benefits of, I would say, of this architecture, because the evolution part is nowadays very important. Serverless is already removing the undifferentiating heavy lifting for the infrastructure part, and if we can also add on top of this a really strong modularization of our code base, I would say that evolving your code base and your project, it becomes trivial. So to wrap up of what we have seen so far, hexagonal architecture is providing a strong separation of concern. It's definitely decoupled the infrastructure from the business logic, but I would say everything that is environment specific to the business logic, that is absolutely great, in my opinion. Is creating, because of this strong encapsulation and modularity, an easy to test code base. And finally, as we have seen, it can be applicable and help in many of use cases that we discussed during this talk. Finally, I wrapped quite a lot of these resources where you can find the demo that I discussed tonight in GitHub. So it's already available on AWS Sample. I also wrote a blog post that is available in the compute blog on AWS website, the original article on hexagonal architecture, and then I share with you one of the books that are talking about hexagonal architecture, that is the domain-driven design book, the red book as it's called, for if you're familiar with domain-driven design. Also a reference on onion architecture, clean architecture, and microlib. Microlib is one of the first architecture or let's say library for Node.js that is that could be used for implementing the petalit architecture that I was describing. Quite interesting concept. Is using module federation behind the scene. That is a Webpack plugin for allowing you to lazy load applications or libraries or JavaScript code or JavaScript bundles exactly inside your application without the fact that on redeploying everything, but just a portion of your code base will be lazy loaded inside your Lambda in this case, or any other compute that you have. That's it for me tonight. I hope that you enjoyed the talk. And if you have any question, I'm more than happy to answer right now. Otherwise, you can find my contact details in this slide. So feel free to reach me out anytime. Thank you very much for listening to me. And now we can open the discussion on the slides. Sorry, on the questions.
Yeah, thank you so much, Luca. We do have one question, although there's not too much context in it, so you might have to have a bit of a guess. So originally it said only testing allowed, but there was a small correction that they meant only texting allowed. Does that give you enough context to what the question is?
Only testing allowed? Not really. Only texting.
I think it was around when you were doing the demo, but if the person that asked the question has any more context, feel free to pop it in.
Yeah.
Otherwise, we might leave that one. A question from me though, it sounds like it'd be really cool adding this to like a greenfield or new projects. I could see how you do it quite quite easily. But I was wondering if you have any advice for people adding it to sort of existing serverless projects, or is there a point where it's not worth to do it anymore? Is there like a point of no return?
Again, it depends from your context. I would say if you have some workloads or some projects that requires a constant iteration, and what I have in mind is imagine like a subscription platform that you are running and evolving, adding new functionalities and whatever. Implementing or refactoring your code towards this pattern, I think could provide quite a lot of help, because the fact that also maybe you're using containers, you want to switch with Lambda, it could be, let's say, a nice evolution that you start first to do a refactoring with Hexagonal architecture, and then slowly but steady, you could basically create the groundwork for then taking some specific HTTP endpoints and move to Lambdas very easily. And when you have done this refactor, then you have a code base that is very modular and therefore is easy to let's say evolve. And I think that could be a good thing. But definitely you can refactor towards this approach. And again, as I said at the end, it depends from the context. It's not mandatory, and we are not saying this is the way that we should go, but is an option that I think it was explored definitely by quite a few people in the serverless community, but I think it was worth it to reiterate and see also from the different angle, sharing use cases, sharing how we can really leverage this architecture pattern.
Nice, that makes a lot of sense. We got a slight bit more context with the word provision. It might still not be enough. It can be a bit hard over text to get the full context sometimes.
Shadab, yeah, I hope that I pronounced correctly your name. If you want to contact me via email, more than happy to answer your question, so you can provide a bit of more context on what you are looking for.
Nice, I think that's a great solution. We got one more question just about if you could give a clear definition of ports and adapters.
Yes, absolutely. So port is, think about port as an interface. So think about TypeScript, for instance, or Java. An interface is just describing basically an entry point towards a method that you can call in the business logic. An adapter instead is a pattern that basically is mapping two contracts: the internal word, in this case, the port, and therefore business logic, and the external word that could be as a primary actor, like we have seen from the API gateway request, or it could be, let's say, a secondary actor, like the storing the information in a database or retrieving information from a database. So the adapter is very, very important, because it's basically saying, okay, I received this information and I will translate to an external entity that could be a database for interacting with it, and encapsulate inside itself the logic related on the communication between the internal word and the external word in this case. I hope it makes sense, Enrico.
Yeah, that is a very clear definition. Thank you. That's all the questions for now. I know you've got some stuff coming up soon. There's a book coming out. Is there anywhere people can keep up to date?
Yeah, absolutely.
With
you
the
can
stuff you're putting
follow
out?
me if you look on any social with my first name and first name and second name. You can find me on Twitter, LinkedIn. I'm quite active on socials, so feel free to add me, and also if you want to reach me for any question, or if you want to have any information, more than happy to answer everyone. I'm a community person, so I really love interacting with people, and I learn from the community, and I want to give back with this kind of activities. Therefore, more than welcome any interaction with you.
Cool. Before I let you go, Luca, Shadiva's put in a bit more context.
Okay, so
now that we're moving to
microservice to Lambda, what would be the best practice to break the microservice so that in future it should not be a mess? Okay, thanks, Shadab, for explaining. Usually my suggestion is, if you're moving from a container that is already a microservice, you're already in a very nice spot, because you already have, let's say, in theory, if the microservice is respecting the concept of microservice microservice that is not a macroservice that contains a lot of logic and a lot of domain, it became easier in that case to say, okay, so I don't know, I'm updating, let's just take this example. I'm updating a user, and I want to create a user, I want to delete a user, I want to update the details of a user, and so on and so forth. So what you could do is base not only, so one of the recommendation is you map one-to-one the Lambda with a specific HTTP sort of REST verb. So in this case, it could be you create a Lambda for read, a Lambda for let's say update a user, Lambda for delete a user, and so on and so forth. My recommendation is adding this information or this recommended path with your context. So if you see, for instance, that you have a lot of read, but not much write and update and delete, you can potentially start with the first, let's say, refactor that you decouple the read from the rest of the other operations. And you create a Lambda just for the read and another Lambda for create, update, and delete. And then when you see that, let's say, you start to have a very complicated logic inside the Lambda, or even your traffic starts to change because you have a specific event that is deleting a lot of users or creating a lot of users, you can start to say, okay, perfect. So now, because I'm using hexagonal architecture, I can extract from a Lambda and decouple that and creating a second Lambda that has a different traffic pattern. And I think it's important not only focusing on the domain-driven design approach or only on the let's say dogmatic approach of microservices, but looking also on the environment, because in reality the context should drive certain decisions. And what is true for one company it may not be true for another one because the context is different. And the understanding the context, it really helps you to decide if it's time to move from a microservice towards one or multiple Lambdas, because your context and the amount of developers that are working on the project, or if you're a solo developer, maybe it becomes easier having less Lambda that are, let's say, handling the traffic. But then you need to look at the next environment information, that is how much traffic you're going to have. And then you look at the overall implementation. I think there are quite a few dimensions that you need to take into consideration in order to decide how many Lambdas you should use in your refactor or your, let's say, migration towards a serverless implementation. I hope that answers your question.
Nice, that's all the questions now. I'll let you go for real this time. And thanks everyone for watching this month. We'll announce the October one soon, and hopefully we'll see you all there too.
Thank you very much.
Bye.